Welcome everyone to Red Team versus Blue Team in Microsoft Cloud.
Welcome.
My name is Mustafa Taraman. I'm Senior System Engineer and Program Architect in company name Authority Partners. Here's my Twitter handle. I'm also Microsoft Azure MVP for the last 3 years, and I'm also very certified in Microsoft technologies, and I've been Microsoft Certified Trainer for the last 7 years.
Hi everyone, my name is Sasha and I'm also an Azure MVP. Here's as well my Twitter handle. You need, if you have a need to contact me or to ask anything, please do so. Like Mustafa, I also like to get certified and has a whole bunch of certification as well. And we're very glad that you're here today. Okay, let's get started. So, in terms of the Azure, the security in Azure, and as in every other cloud, represents a shared responsibility. What does that mean? It means that the security is treated in layers, or as we would say, as onion layer security, as someone called it like that. Because the security comes in layers, first physical, then infrastructure. As you can see, the physical security consists of cameras, security stuff, and two-factor access control, everything that Microsoft is doing to prevent and to control the access to their data centers. And the infrastructure is means the Microsoft integrates the operation security controls and does the regular penetration testing and everything else to be secure, to ensure the security of its infrastructure. In these parts, we as customers, as people who has subscriptions in Azure, don't have direct access and or influence, and that is where Microsoft is doing his job. But in fact, when we go further inside this circles of security, network and VMs and apps, the inner two circles is where we can and must do our best to ensure that our data is mostly secure. Because as, for example, if we have a weak security on SQL database, any kind of breach, for example, like a cross-site scripting or anything, any kind of flaw in design will result in data being leaked or breached. So, despite this, the Microsoft is providing security for its own circle of influence, we must do so as well in our circles in influence too.
So, and as Sasha mentioned, it's a shared responsibility level, and we have to take part in securing our infrastructure and securing our resources in some part, especially as mentioned in the last slide on network and VM and application level. So how we actually do that? Microsoft enabled a lot of security services, and here circled ones are the ones that are basically mostly connected to security, most usually connected to security. But every Azure service has some kind of security feature built in by design. So these are basically the most important security features, where we have a security dedicated services or networking services that are usually connected to security, but every service has some kind of built-in security as well, and we'll show that in a bit.
In Azure, so we are building our data center, and actually what Azure provides in the first layer, that is the virtual networks and security groups. The virtual network infrastructure level is that Azure provides a perfect network isolation, and network isolation actually enables tenant-to-tenant communications, and thus prevents unwanted or unneeded tenant-to-tenant communications. And also, it can access control which users can access the network, whether authorized or unauthorized. So virtual machines usually do not receive any traffic unless we configure them to do so. We also can encrypt communications. So between Azure regions and from Azure to on-premises data center, we can encrypt the communication with us. And also network security groups also enables us to provide control over network traffic. And we have also the VPN connections to which by which we can ensure our connectivity to on-premises cloud. So whether these are secure point-to-site connections or site-to-site connections, we are able to securely connect our on-premises centers to our Azure infrastructure. And the threat detection in Azure provides us, actually prevents any distributed denial of service attack, and it can help mitigate threats from outside the world, as well as the attacks from the inside, perhaps from other Azure subscriptions. So not only this, but the Azure is Microsoft Azure is able to provide us logs with logs for intrusion detection and prevention detection, and if any anomalous activity is detected, we are notified, and the incident response, the threats are mitigated, and the incident response is triggered. Also, it regularly performs the penetration testing, and in terms of DDoS prevention, employs prevention measures for the Azure platform. So we, as a customer, have additional protection, and now that we have actual DDoS protection has been always there, but now with the inclusion of the second tier, we are now aware of it and can leverage the additional logs and additional logging and information that we can gather from it. So, what do you think the biggest threat in modern security is, Mustafa? Do you have any idea?
So the biggest issue in modern security is definitely human error, because on the one side we have all those firewalls, encryptions, antiviruses, machine learning, threat detection, and so on and so on and so on, and security, cybersecurity evolves constantly, but most attacks happen still because of the human error. Most common reasons for data breach are still being either phishing attacks or social engineering, and over 80% of all data breaches happen because of delete credentials. In Azure Cloud, in Microsoft Cloud, we use Azure Active Directory as a form of authentication to our cloud services, and Azure Active Directory is basically extension of our local identities. It can be synced. We can import our on-prem credentials there as well, and use this to identify users and allow them access to different services, either Office 365, Azure resources, or custom cloud applications. So Azure Active Directory also has a very cool feature called multi-factor authentication that requires additional confirmation along with classic username and password. Actually, from a couple of days ago, another form is announced, allowing you to authenticate without a password, only using your additional authentication methods. But how does it really work? So when user tries to sign in, providing username and password, additional confirmation is requested. We can use multiple devices for this. It can be a mobile device, it can be biometrics like fingerprint, or it can be third-party token on any other kind of device. Mobile device is most common because almost everyone nowadays have one, and on mobile device you can configure either authentication application, you can configure SMS or phone call authentication. So let me just show you what I said how this actually works. So Sasha and I are often roommates at the conferences. So one night we were working and he just left his laptop unlocked and left for the bathroom. So such a security expert like he is. And let me show you. I got ahead of his credentials and I'll try to authenticate now. I hope I remember the password. Yeah, I do. But unfortunately for me, Sasha still has multi-factor authentication enabled. So even though I have his credentials, I won't get through. Yeah, so he request is denied. He actually denied the request. He's saying he used his device. He got a notification. You need to confirm that you're signing in? And he said, no, you're not signing in. And there are multiple other features you can use with this as well. So after he denies the request to sign in, it can be sent to administrator as a notification that someone is trying to breach account and similar things as well. Okay, Sasha, take off.
And there's another thing that we can use to enhance the security in our Azure infrastructure. So the Azure Key Vault and the Azure Key Vault will help us to mitigate, to solve the security problems in many ways. For example, we can store our secrets within the hardware security models. Then these are protected by software or hardware FIPS level hardware security models. So we can, Azure Key Vault is also a service that we can use to deploy public and private SSL and TLS certificates that we can use in Azure and with our resources. So it provides a key management as a key management solution. It provides the key management, and we can easily control encryption keys and create encryption keys to use to encrypt your data. So it also controlled access to tokens, passwords, API keys, and other secrets as well. So what we do have for encryptions at rest, actually we need to secure our data, whether it's moving or staying still. And within virtual machines, we then we can protect our data drives by full disk encryption through BitLocker, or boot drives that can be provided by third-party partner solutions. And for the SQL Server, we also have transparent data encryption that we'll see later how it works. EFS in Windows Server is here as a basic security setting, and if we want to secure storage, and then we also have BitLocker encryptions for exporting or importing the data. And if we're using Store Simple, then we also have the AES encryption to secure that data as well. Applications can be protected by RMS SDK, and also the disk encryption in VMs. The VMs are used, and the security at rest is used by using encryption topology. And VMs, if we encrypt the VMs, actually the VMs boot under customer-controlled keys that are stored in VMs in key vaults and policies. And we can audit the usage of these keys in Key Vault. And also what we are addressing with it. We are addressing also storage account keys or a possible data breach, and if we'll lose disk and so on. So we just need to opt in for or manually enable disk encryption, and that's it. So in the terms of the SQL encryption, we also have Mustafa, you'll say that better than me. You're very well versed with databases, please.
So before we switch to SQL, let's stick to virtual machines and disk encryption first. So I have a virtual machine here, right? So if I go to disks, I can see that encryption is not enabled right now. And I'll just pop up this PowerShell command that will use my key vault and my custom key to encrypt this disk. So if I just execute this command, it will start the encryption process. After a couple of seconds, I should have a pop-up message, and here it is. And now it will probably take some time to complete this. So we'll jump to SQL part and continue discussing other methods and what we have. So for SQL encryption, we have also multiple methods. There's encryption in transit, of course. Everything goes through 3LS, same as most Azure services. For encryption at rest, we have TDE, and we can do encryption end-to-end using libraries for client-side encryption. But let's show a couple of examples on how Azure SQL database is actually also secured. So let's leave this for now, and I'll pop up to SQL. And first layer of Azure SQL security is a firewall. So if I go to a firewall, I have a couple of things here. It's configured to only allow connection from a trusted IP address. So if I go right here and try to connect, I'm trying to connect to this database, I will get the notification that this IP doesn't have access to a server. So what I can do now is sign in here, and it will allow add new IP address, or I'll cancel that and I'll go back to my Azure portal and I'll say add client IP address. Now, very important thing is you have to save firewall rules, because it happened to me on multiple occasions that I clicked add client IP address, tried to connect, but didn't save in the process. So you have to update firewall rules in order to connect. So if I try connection again, now I'm good. I'm ready to connect, and I can access my database right now. So that part is good. Okay, so another thing that you need to notice about firewall settings is this feature right here. So it says allow access to Azure services, and by default it's enabled. Now, most people probably think that it's a very good idea to allow my Azure services to access my database, but this isn't the thing. This feature only checks if the connection to your database is actually coming from Azure data center. It's not actually checking if it's coming from your subscription or your tenant. It's actually checking only if it's coming from Azure data center. So anyone can actually create a trial subscription and try to access your database. Of course, they will still need username and password to do that, but it's much easier. Okay, for the next part, let's go to security part. So we have advanced threat protection. We kind of discussed some features about it. It actually detects any unusual behavior. So if some users are usually connecting to database only from your standard IP, from your company IP, and only from 9 to 5, and suddenly start connecting from Hong Kong in 2 in the morning, you'll get a red flag and get notified that something out of the ordinary is happening. You can also enable auditing logs. You have dynamic data mask that will mask certain fields and not allow our users to see them, and transparent data encryption. So anyone who did transparent data encryption for on-prem servers now knows how much work it is, with certificates, master certificate on the SQL server level to database level and so on. So you have to keep track of everything, and it can be very complicated. In Azure SQL database, all you have to do is click on and click save, and this will enable your TD. Simple as that. Now, keys for encryption and certificates are actually then provided by Microsoft. So some people don't want to do that and want to go one step further and manage that on another way. Let's show example of how can we do that. So, by the way, disk encryption is finished. We'll check that in a bit. So what we do now, I'll have another I have another PowerShell command that I'll execute, and this will actually create encryption of my SQL database, again using a key from Key Vault. So if I execute this, it should take not so much time. It's much faster than command for disk encryption, because it's a small sample database that I want just to showcase. While this is going on, let's go to my virtual machine. My virtual machine again, and if I go to disk, now encryption is enabled, so we're good to go on that front. Let's go to this. Okay, so it's asking if I want to proceed. I want to proceed, and the encryption should be done any second now. So it's done. So if I go again to my Azure SQL database and say, okay, what's the status of my TDE? It's still off. Strange. Okay, now it's in progress. It's encrypted, and now it says encrypted.
It's a feature.
Yeah, it's just because I got it in a second where it was doing something. So right now it's encrypted and it's all good. If I go leave and go back again, we can see that data encryption is now on and it says encrypted. I just got it in the second between it was really done. Okay, let's continue. Sasha?
Yes, and to sum it up, and our Azure, as we said in Azure infrastructure, as we said at the beginning, we need to we have a shared responsibility model, and to protect us further, we have also a numerous third-party solutions, whether to protect from malware, or from to further enhance networking security, or to encrypt our data and monitor, whether it's to authenticate and so on. There are numerous third-party vendors that are famous and popular, like Trend Micro and Cloudflare, F5, Cisco, and so on. So if the, let's say, it's not so basic, Microsoft features does not have any features that you might want to have it, then you can easily expand your security with these third-party solutions that are that you can find in Azure Store. And yes,
and
say, Mike.
Yeah, and the last piece of cloud security, Azure cloud security, is basically Azure Security Center. It's a piece that actually tries to tie all security features together and provide you as much as possible information on security. Let's pop up to demo and show bit stuff. What can we see in Security Center? So we have a lot of information about policies, compliance. We can track our secure score, how secure is our environment. It uses machine learning. It analyzes our services and compares them to best practices and gives us additional recommendations on how can we even increase our security. So for example, let's go to events. In events, I can open logs, and I have, let's say, events for last 7 days. So I have almost 300,000 security incidents in last 7 days alone. So if I go in there and say, okay, let's see what happened over the last 7 days, I will get a list of all the security related incidents that happened. So it's like pretty extensive list, 280,000 security incidents, and I can see what was happening in here, who tried. So I have multiple security events when an account failed to log on. We can check the list. It's extensive list. So basically, these are almost all brute force attempts on my virtual machines, trying to use various users, local users, administrators, and so on. So it's a good thing not to use accounts like admin, administrator, root, and more sysadmin and similar things. Fortunately, Azure virtual machines don't allow those kind of usernames, so that's basically a very good thing. Okay, thank you everyone attending our session, and if you have any questions, please reach to us.
Thank you very much for your attention, and see you in the next session. Bye-bye.
Bye.